So today we're going to talk about learning target 8, which is defining and evaluating functions using function notation. When an equation is a function, which we talked about earlier, we can write the equation using f of x equals instead of y equals. F of x, right there, let me zoom this in a lot here. F of x is function notation. This means that the function is called f, so this right here, that's the name of the function, f in this case. And we are going to put different values of x into this function. However, you can use different letters besides f and x depending on what you want to call the function and what you want to put into it. This is helpful if we are working with more than one function. So there are two main benefits to using function notation, and that's the first benefit. You can name functions based on their context. For example, if you have a function about the money that you earn, you can name it M for money. The second benefit is you can tell functions apart when dealing with more than one function. So consider these functions. We have f of x, g of x, and h of x. And each of them equals something different. F, g, and h are the names of the functions. We're going to use these functions to find these values. So if we want to find f of 4, this f right here tells us to use function f, which is right there. Now whatever is in the parentheses, that's what x is. So as long as this is still an x, there's still an x in the function. But if we want that to be a 4, that tells us that we are going to evaluate that function when that x is a 4. So f of 4 equals 3 times 4 is 12 plus 1, which is 13. H of negative 2 means that we're going to use function h, so that's over here. And instead of the x, which was here, now there's a negative 2. So this is going to be 10 times negative 2 instead of 10 times x. And that equals negative 20. For this function, it's g, so we're going to use this function, and we're going to put a 5 in for x. So it becomes 5 squared minus 2, which is 25, minus 2, which is 23. Notice that every time I put a number in for x, I put that number in parentheses. That's just a good habit to get into. Sometimes it matters, sometimes it doesn't. And so just to make sure, you can just always put it in parentheses. Down here, these two are a little bit different. Because we could also write this as y equals 3x plus 1, f of x is just another way to write y. This is actually saying find x when y equals 64, because f of x is really just like y. So we're actually going to put 64 in to where f of x is. So this actually becomes 64 equals 3x plus 1. And so then we're going to find x when we put 64 in for where the f of x was. So I'm going to have to subtract 1 from both sides, and I'm just solving this equation like we've always done. So now I have 63 equals 3x. Divide both sides by 3, and x equals 63 divided by 3 is 21. Same thing here, find x when h of x equals 12. So what I'm going to do is I'm going to put 12 in for h of x. So I actually have 12 equals 10x. Okay, so this 12 went where the h of x was. So 12 equals 10x, divide both sides by 10, and I have x equals 1.2. Now we can also use function notation when talking about a graph. Remember that f of x is the same as y, so consider this graph. If we want to find f of 4, this means the same as what is y when x is 4. So when x is 4, because remember whatever is inside there, that's what x is. So 1, 2, 3, 4, this is where x is 4. And when x is 4, y is 2. When f is 1, or when x is 1, y is 3. When x is 2, y is 4. And when x is 5, y is 0. Because whatever is in the parentheses, that's the x. And we want to figure out what y is. This whole thing means y. That's the x. So we want to know what y equals when x is 1. And what y equals, this whole thing is y, when that x is 2. Now down here, let's try it the other way. This means if we want to find x when f of x equals 7, what we're really saying is what x value gives you y equals 7. So we know that y is 7. We want to find x. So here's when y is 7, way up here at the top. And that is the point 37. So when y is 7, x is 3. When y is 4, we're going to find x. So when y is 4, here's when y is 4, over here. X is 2, and x is about 3.6. We estimate that. So sometimes you're going to have to estimate. It won't always land right on a normal integer spot on the graph, but that's okay because estimating decimals are numbers too. So that is how you find, that's how you use function notation and evaluate functions using function notation. Now we're going to practice this a lot.